So I want to thank you for being here today. Privacy is maybe not the most popular topic for all audiences, so I really want to thank you for being here and taking some time with me today. This is my first time back in the States for several years, and I just got to say a few things have changed since I was last here. But some things have remained the same, and it's really nice to be here and to be talking with folks about a variety of issues that we face today. A little more than 4 years ago, the streets of St. Louis and Ferguson erupted in protest. This was after the killing of Michael Brown, an unarmed black teenager, by the police. And regardless of your political affiliation, regardless if you looked at these protesters as angry or brave, as justified or simply unsatisfied, regardless of your interpretation of the protests in the street, Black Americans and their allies of all races and ethnicities and backgrounds took to the streets to protest unfair treatment by the police towards citizens of the United States. And this sparked perhaps a conversation that maybe was ongoing in many communities for a long time, but maybe as a nation we hadn't had. As a United States nation, maybe we hadn't had in a while. And as an international audience, perhaps we hadn't had in a while. And it's no secret that the foundation of the United States is based off of several values that today we would classify as racist, sexist, and oppressive. This has been well documented within the Founding Fathers and the formation of this country. But what we ask ourselves now is, given our current situation, given perhaps an evolution of societal values, can we remove these influences from our society? Can we rebuild institutions so that they do not continue to profit off of these historical prejudices and imbalances of power that we still see today? And perhaps one idea for this is to use science, right? Perhaps an idea is we can use science, and maybe we can use data science, to extract ourselves from these societal ills. And by using data and science, we can fix the problem. Now, I don't know if anybody here went to Stanford or knows folks at Stanford or professor at Stanford. Stanford is pretty well regarded within our field of computer science and has helped evolve quite a lot of interesting ideas. But Stanford's first chancellor is here. His name is David Starr Jordan, and he was a eugenicist. And eugenics, in case you're unfamiliar, was potentially one of the most harmful classist and racist movements within the past century. What eugenicists believe, and they used science, I use science in very heavy air quotes here, they used science to prove that poverty was based on genetics, and that somehow poverty was inherited, that people were born unfit. They were born unfit to survive in society, and how we were going to fix poverty was we were going to make sure that those people didn't reproduce. We were going to let those people die out. And this allowed many forced sterilizations, and these forced sterilizations often happened to poor women, immigrant women, and women of color. They're vastly overrepresented in the groups of forced sterilizations. And this was all in the name of science, right? This was this progressive era. Let's use science to fix humanity and social problems. And artifacts of the eugenicist movement, even after it fell out of favor and people started to criticize it, artifacts still exist in our culture today. So how many people here have taken an IQ test? Or the SAT test? Or a personality test that tests your aptitude for a particular job or career? These all have base and were first published by the eugenicist movement. And there are ways that we can measure intelligence, measure fit. And hidden within these questions is often racial, class, and cultural biases that we continue to use in a scientific way. So maybe we can do better than the eugenicists, right? Maybe we can get it right this time. Maybe we can use data and the ability for us to collect quite a lot of data to, this time, document police brutality, right, or police mistreatment of individuals. And I was walking around St. Louis yesterday. I don't know if you saw these around, but they were quite prominent to me. They're on quite a lot of the stands. And maybe this might help, right? Because if we have body cameras and these videos, maybe this might allow us to expose unequal treatment of individuals. And the optimist in me wants to believe that this could be the case, but the pessimist in me worries a little bit about how this data will be used. The skeptic in me worries that maybe this data will not be used to help prove unequal treatment, but instead prove cases where the treatment was seen as just, and instead choose and cherry pick cases where it seems justified, and suddenly you lose data or lose analysis at a greater perspective. And so another possibility is we know humans can be prejudiced. We know humans can be biased. So one way that we could potentially fix prejudice or bias is by allowing computers, allowing algorithms or something like this to do the work. Because algorithms are neutral, right? We know we can write neutral algorithms and that they can learn from data and that perhaps this will fix the problem. Because by default, the algorithm is perhaps not going to treat a particular group different than another. So maybe this is the solution, right? Predictive policing, predictive sentencing, and so forth. But the problem arises in the fact that machine learning and algorithms, by definition, we ask them to discriminate. We ask them to discriminate. We say we would like you to make a recommendation or we would like you to make a classification of this particular individual versus this other, and so forth. We ask them to form decision boundaries. We want them to make these choices. And then when we feed in historic data that reflects our own societal injustices and our own human prejudices, then all of a sudden we become very surprised when they act even more racist or sexist than any human would openly do so. So we ask them to discriminate, and then we feed them discriminatory data, and then we're surprised. And I don't really think we should be surprised, right? And I think quite a lot of people, of course, aren't surprised. And this is the problem that we deal with today. And there was a paper that was presented at the Fairness, Accountability, and Transparency in Machine Learning conference this past year that mathematically proved the feedback loop that occurs within predictive policing environments. Because you can imagine, an algorithm that we use to make a decision about whether a person will commit a crime or whether a community or an area of town there will be crime there. We feed in this historical data, which has an overrepresentation of a particular group of people or groups of people or particular neighborhoods. The algorithm adequately says, okay, you should go to those neighborhoods, and then you go to the neighborhoods and maybe you find crime. And what this feedback loop does is eventually 100% of the police officers are deployed in 1 or 2 neighborhoods. Now, what is the statistical likelihood of them arresting someone in a different neighborhood if 95 to 100% of them are deployed only in 1 neighborhood? So we have created essentially our own feedback loop, and we have created essentially an algorithm that is just as prejudiced, if not more so, than a human would be openly. And so, as follows, privacy in our society today operates as a form of privilege. Because of my skin color, because of my education, my class, and so forth, I can use privacy. I can turn it on and off at will. Privacy is a privilege that I experience every day. But if the situation were different, I may or may not have access to this privacy. I may not be able to control what data there is about me. So I give us an example. How many people here have used a loyalty program, airline rewards, and so forth, right? How many people have used this in the context of buying groceries, that you enter your phone number so you can discounts on groceries? How many people geotag themselves on Instagram with all their friends and so forth? I'm starting to see some head shaking. Some people yes, some people no. Or sign in for free Wi-Fi, where you have to just simply say your nationality, your email, or your address, things like this. Now, depending on your knowledge and your, we might say, paranoia of privacy and security, you may or may not choose to operate these in different ways. So you may have a level of security or technology literacy that is helping you make choices about what to engage with here and what not to engage with. But all of us have choices, right? We're all making these choices. We're opting in to share this private information. And I don't want people to raise their hands, but I'm going to guess that very few people in this room have had to go through the process of applying for food stamps. And when you apply for food stamps, here's just an example from the state of Missouri. These are all the different documents that they ask you to produce before you can even begin the application for food stamps. And then once you get the food stamps, quite a lot of states have implemented electronic cards for food stamps. And so they're going to track every single transaction that you make. So you're already at a disadvantage. You already need assistance. And then you are forced to give up your privacy to obtain that assistance. There is no other way for you. So privacy in our society today acts as a privilege. And where there is privilege, there is usually power. And privacy operates very much as a power in our society. So when you think of a business negotiation, when you think we're going to do a business transaction, what we want is we want to be on a somewhat level playing field, right? I want to know about as much information as you know, so that when we get into the bargaining, we kind of can go back and forth. But the problem arises when we have what is called in economics information asymmetry. And information asymmetry in economics is the ability for one party to manipulate the sale or the transaction in some way, shape, or form because they hold more information. And information is powerful, right? And so when we think about this in an online privacy context, do we know how much information the online retailer knows about us when we go to perform a transaction? Do we know if they know how much we're willing to pay for it? Do we know if they know that we've been looking for this for some time? Do they know our location? Do they know our salary history, our political affiliations, and so forth? And the problem here is that there is an inherent information asymmetry in quite a lot of the way that we do online advertising and quite a lot of the way that we do online sales in general. And the consumer knows very little about what the producer knows about them. And this leads to a situation where they cannot really negotiate the transaction. And the more that, let's say, the vendor or the company knows about the person, the less chance the person has to insert new information as perhaps a bargaining chip, right? So if you don't need any extra information from me, you already know everything that you need to determine the price or determine my eligibility and so forth, then I don't have any power to come back to you and say, oh, actually this. And there's very few online transactions or online interactions where we can insert extra knowledge that we have or an extra condition that we have and so forth. And so this imbalance of power operates when we think about privacy online. And so privacy is privilege, privacy is power, and privacy is also security. And what I mean by privacy is security is a two-part answer. The first is privacy is information security. It's literally do I control and do I have determination over the security of my personal data? And as follows, if my privacy is often violated, or if my private information is available in many different ways to many different vendors for different prices or availability, then I do not control the security of that information. I depend on some company, the government, and so forth. I depend on them to protect my privacy, but I don't have control over that. And with security, it's often not if, it's when. And the problem that we have with security is now we have more and more public data sets, and the ability to link these and to create a more full profile of an individual becomes easier the larger data sets we have and the more big data solutions that we have to help us with these linkings. And the second part of privacy as security is societal security. Now, societal security and political security, we might argue, is our ability to trust our society. It's our ability to trust one another and the institutions that we use on a regular basis. And when we take a look at something like Cambridge Analytica, we can see an erosion of our societal trust. This is similar with fake news and other phenomena like this. I share my private information with a company like Facebook. I assume that they're going to keep my privacy in mind. Whether or not you can argue that Facebook API was operating as designed or that it was a privacy breach is neither here nor there because it happened, right? And Cambridge Analytica was able to build these political profiles and use them to influence people. Now, one could argue maybe those people would have done whatever they did anyways, but that extra nudge may have helped. And the fact that now there is a constant debate over what we can trust when we see online and what we can trust when we work with companies like Facebook, this erodes our societal definition of security. And so with privacy and fairness, if privacy has all of these attributes, it's a form of privilege, it's a form of power and security, then as follows, privacy is unequally distributed. Privacy is not equally distributed amongst people within the US society and maybe even within society as a whole. And this becomes a problem because quite a lot of people that do automation, machine learning, these types of things with other people's data, quite a lot of us actually benefit from eroding our own privacy. So I'm willing to give away my data because it usually works out for me. Siri is helpful, it's convenient. Instacart means that it knows what I want to order and it delivers it right to my door. These are things where I benefit from giving companies more data about me, and it creates nice things in my life. I want to do this. But that's not the case for everyone. And because privacy is unequally distributed, and because some people don't get to opt in to sharing data, this creates an unequal treatment. And in Virginia Eubank's book, Automating Inequality, she went and studied several different automation infrastructure within services for people that don't have a choice about their privacy in these situations. She looked at a welfare system in Indiana that was automating things. She looked at Section 8 housing in Los Angeles and getting homeless folks off the street there. And she looked at child services in Allegheny, Pennsylvania. And what she was able to show through a series of very eloquent stories, journalism, and also statistical research is that for poor folks in the United States, privacy means inequality. And the automation and control of more of their private data usually means further inequality for them. And therefore, this unequal distribution of privacy within our society means that we have unequal treatment and unequal experiences of data collection. So this leads us to what we could possibly do about this situation, right? I'm so-called data scientist, I do machine learning. I would like to use data to help society rather than hurt it. And so how, in knowing all of these things that I know about privacy, how can I do this in a thoughtful and appropriate way? Now, Cynthia Dwork should hopefully need no introduction, but I will give a brief one just in case. She's a researcher, and I would say an activist within the field of data privacy and data security. And she is the creator of differential privacy, which you may have heard about as a measurement to measure privacy loss within a database system or other queryable system. This was a new, more strict definition than previous definitions of privacy loss that we had used, and is really fantastic and can hold us perhaps to a slightly higher standard when we think of private data collection. And after her paper on differential privacy in 2011, she released another paper that continued to explore privacy, called Fairness Through Awareness. And the concept behind fairness through awareness is we should treat similar people similarly, meaning that all things equal between you and I, myself as woman identified and you as man identified, all other things equal, that we should be treated the same way by, let's say, a classifier. And what she was able to theorize and mathematically prove is that there exists a mapping space, an intermediary space, where we can create a fair metric or fair representation of a person. And that this similarity that we see within the input space, where the only thing different between us is perhaps a private attribute, like my gender identity. If everything else is similar, then we should be able to hold that same distance within a classification space. That should not be the sole reason why I am treated differently than you, should not be this private attribute or these series of private attributes, depending on if you're thinking of multidimensional space. And so in Fairness Through Awareness, she was able to prove that indeed this space exists. And further research on the topic began to dive a little bit deeper in how this intermediary space, or this mapping, can be used within the field of machine learning. And so a later paper made by the University of Toronto, or several researchers at the University of Toronto, along with Cynthia Dwork, was called Learning Fair Representations. And in this work, they actually implemented her idea of this fair mapping. And what they were able to show is, here, let's take the graph on the left. They have the UCI adult data set. This is a data set that's used in machine learning often to talk about ethical or fair machine learning, because it has all of this data about individuals, including their age, their race, and their gender. And the target attribute, or what we're trying to learn, is whether they make more or less than $50,000 a year. And so as you can imagine, this displays some, let's just say, societal prejudices towards different races and gender and age. And what we have here in the yellowish on the far left of each of these accuracy and discrimination is the logistic regression. So this is the baseline. This is, let's not try to be fair, let's not try to retain privacy, and let's just learn what we can learn. And what we have on the far right, or the dark blue for each of these charts, is the learned fair representations. And we can see in both of these examples that the accuracy is quite high, so we retain a lot of utility in the data, but that the discrimination is quite low. And the only difference between these charts is the optimization that they use. So either minimize the discrimination or maximize the delta between accuracy and discrimination. So we want as high accuracy as possible and as low discrimination as possible. And the other bars that we can see, these are other ways that we think about ethical machine learning. It's a fair Bayesian approach, as well as a regularized logistic regression. You might be thinking, okay, how does this work? This sounds great, right? Accuracy, high accuracy, low discrimination sounds great. How does it work? Well, it works by optimizing three things. The first thing that it attempts to optimize for when finding these fair representations is that the mapping from X to Z space satisfies statistical parity. And what this means is the mapping is fair. Now, statistical parity was used within the paper, but we can use other definitions of fairness. We can use other definitions of algorithmic fairness if we want to. And Arvind Narayanan is a fantastic researcher who has released recently 21 different definitions of algorithmic fairness. So we can choose, depending on our task, how we want to define this fairness. But the first requirement is that it maps this statistical parity, which means fair treatment for groups. The second thing that it asks is that the mapping to Z space, which is this fair representation space, retains information in X outside of the private attribute or the private variable. And what this means is we retain as much information as possible without retaining information about this privacy aspect. So we want to retain information, but we don't want to learn whatever we want to keep private. And this is, of course, difficult to do. Not impossible, but difficult. And the third thing that we have is that the induced mapping from X to Y, and I'll skip the parentheses, is close to F. And this essentially is quite a long way of saying that we retain some level of accuracy, that we can find an accurate representation of the output space so that we can do machine learning, right? Because if we destroy all information, and if we destroy all target information, then we can't do machine learning. And for those of you within the machine learning space, maybe you're already familiar with this paper, but if not, you're thinking, these are contradictory optimizations, and you're right. So depending on the task, these optimizations can play against one another. And in order to find a solution, we have to tune it and we have to decide what is most important for the task. And sometimes this is going to be very difficult because sometimes this is going to mean that we find out that the only indicator of whatever target we're trying to learn, the only indicator of making over $50,000 a year is that you are white and a man. And if we find that out, this is going to be very difficult for us to figure out a way to do this that is both fair and respects the privacy of the individuals within these groups. Another way to solve this same problem is to treat it as an adversarial learning problem. This was actually a paper that was released earlier this year, which I think is really fantastic. And this adversarial relationship to learn these fair embeddings is something that we can do. But I first saw it at Go Data Driven, which is a data science consultancy based in Amsterdam. And within adversarial learning operation, what we have is two machine learning models. One that's trying to do one thing and another that's helping with the error of the first one. And in this case, we have the same adult data set, and the first classifier is trying to classify, is this person in above $50,000 a year or below? And the second machine learning model is trying to guess or predict the private attribute based on whether the person is supposed to earn above or below $50,000 a year. So it's essentially trying to erode the privacy of that group. It's trying to say, oh, okay, less than 50,000, it's probably a woman. And this loss, the more accurate that the second discriminator model is, this counts as loss towards the first algorithm. So the first algorithm has these competing optimizations between fairness and privacy and accuracy. And after 150 iterations, it's a deep learning framework, so after 150 epochs, we see that we meet the requirement for disparate impact, which is a legal requirement within the United States as far as employment goes. And so back to our initial question, which is, can we do data science in a way that allows us to expose societal ills while perhaps not inserting issues of privacy, right? Because we don't want to violate people's privacy, but we'd like to potentially use data science to help us fix social problems. Well, one way that we might be able to do this is to collect data in a private manner. And if I can guarantee your individual privacy, but prove that there's unfair or unequal treatment for a larger group, then this creates a space where you can safely share information with me, and we can perhaps fight societal injustices together. Because, as is happening in the US Congress today, what usually happens today when we want to fight unfair treatment is some individual has to give up more of their privacy. Some individual has to go forward, or a larger group of individuals have to go forward, and they have to erode their own privacy and potentially face even more unequal treatment. And perhaps there's a better way, right? If we smart software engineers and machine learning engineers in the room and so forth, perhaps we can find a better way. And I put this slide up as an example. This is from the New York Times, but it was data collected on a Google internal spreadsheet whose aim was to expose the gender pay gap at Google. And there's some women that are using this data, along with their own personal experiences, to file a class action lawsuit against Google based on the pay structure that we can both see here from the spreadsheet that people opted in to share their data for, and also the individual experiences. And perhaps if we have better data collection like this that ensures individual privacy, perhaps we could eventually even have class action lawsuits that do not have to erode the privacy of the individuals cited within that lawsuit, particularly not in a public way. Which leads me to privacy by design. We cannot collect data and use data in a private way unless we implement our products in a way that ensures privacy by design. Privacy by design is founded on seven foundational principles by Anne Cavoukian, I believe. And she published this years ago and said, here are the different things that we can implement as software engineers, she's a computer scientist, as software engineers, to ensure privacy by design. Because if we can make privacy the default in the products that we build, then the data collection that we do and the services and the systems that use this data can be more fair. And we can perhaps ensure more fair and representative treatment of individuals not based on a private attribute, while still being able to explore unjust or unequal treatment of a larger group. And that is exactly what I'm currently working on at KI Protect, is how can we make privacy by default easy? How can we make it so you do not necessarily need to be a privacy expert to implement proper privacy in your data processing at this moment in time? And how can we educate not only the people that are working with the data, but the end consumer, the user, so that they can determine the level of privacy loss that they're comfortable with? Because privacy is not an on or off, it's an entire scale. And so this is something I'm incredibly passionate about and hopeful that we can solve. Because what I believe is that privacy is a fundamental right. And when the GDPR, the General Data Protection Regulation, was first being written and then passed the EU Parliament more than 2 years ago, it started a conversation saying, would this be a game changer? Would this mean that large corporations would rework their architectures to ensure privacy by design? Privacy by design is actually one of the fundamental principles of GDPR, and there was a lot of debate and hope. Maybe this was going to change things, you know? Maybe privacy rights were going to be for everyone. But we see how GDPR hasn't been implemented thus far, right? GDPR has essentially created what I like to call first-class and second-class data citizens. If you have the luck to live in Europe, then you have some fundamental data rights. We can argue whether they're perfect, we can argue whether they're gonna be implemented right, we can argue about all of those, but you have a legal precedent and right and access and actions for your data. And instead of changing this for everyone, what this has meant for other nations is business as usual. And what this has meant for other nations is just more of the same. And it was a little bit terrifying for me on May 26th when I was surfing across the internet and I saw how many, of course I have also VPN, so I can see all the US sites still, but I saw how many of the US sites turned off access. And I had this moment, which was similar to the day I woke up and I saw the news about Ferguson, because I had this moment where I felt like I was looking in the mirror. And I said, what have we become? What have we done where some basic privacy principles in our data processing, where rather than implement those, we'd like to turn off access for an entire continent? This, for me, was a disturbing day. But I'm still optimistic and I'm still hopeful. And here we have Lady Justice. She was a Greek goddess and then a Roman goddess, and she's shown in quite a lot of the courthouses within the United States and many other nations across the world. And she's shown often with her scales, which show her equality, her fair treatment. She represents law and fairness and order. She's sometimes shown with a sword so that she can defend justice. And she's often also shown with a blindfold. And the blindfold represents the fact that she does not mistreat individuals based on something that she sees in them. She's not going to mistreat or choose a different sentence for you based on your skin color. She's not going to ask for your gender before she determines if you can get health insurance. The idea is that she is blind to these private things about you. And my challenge for us is that as machine learning engineers and practitioners, as software engineers and practitioners, we can use our intelligence, we can use our ingenuity, we can use all of the knowledge that we have to figure out a way to implement something more like Lady Justice, to implement something where you can have control and rights over your data, and you can have privacy, and you can have truly implemented privacy, which is, I would argue, our final stand for fair algorithms. Thank you very much.